We're still taking a look at the advanced functions and modeling indicators, standard 2.04. Still working with the example 2, but we are on part D of example 2. It's rather lengthy, so I decided to do an extra video for this. So let's get right into it. It says if k of x equals 3 sine of 1/2 x minus pi over 2 plus 1, describe the transformation from f of x. So we want to work with our parent function first, and that's going to be f of x. Now with f of x, we had an amplitude of 3. We had a period of, let's redo that. We had a period that was 4 pi units. We had no phase shift, and we had no vertical shift. Okay, now if we compare that to k of x, which they give us here, k of x actually has an amplitude that is 3 still. It has a period that's a little different this time. Okay, so the period this time for k of x is actually equal to 2 pi divided by 1/2. In this case, b is equal to 1/2. So that's that right there, that coefficient of x. So we have 2 pi over 1 times 2 over 1, which equals 4 pi. Okay, and then we have a phase shift that changes a little. It's pi over 2 divided by 1/2, which that gives us pi over 2 times 2 over 1, which is 2 pi over 2, or simply just pi. But it's going to move to the right. Okay, it's going to move to the right 5 units. Okay, and remember, this is a minus pi over 2, but the graph moves in the opposite direction of this sign. So if this was plus pi over 2, the graph would move to the left. Very important point to remember. Vertical shift is going to be, it goes up 1. Okay, so here we're going to graph this function, and these functions at times can be pretty weird to draw in this program. So we're going to start with the first one. Remember, the sine function starts here at the origin, and we have amplitude of 3, and we're going to go up, come back down to -3, and we're going to finish a full period at 4 pi. We're going to go up again, come back down to -3 again, and we're going to finish. And that will be the graph of f of x. Now, k of x changes a little bit. It shifts up and to the right one. So let's change our color back to red. So if we picture starting here and we go, let's do x first. So it shifts to the right 1 unit, and then it shifts up 1 unit. So it starts here. And so here we still have a period of 4 pi, still have an amplitude of 3. So from here we're going to go up to 4 and back down to -2. Okay, and then we're going to come back up here and come back down here. All right, so that's how that graph looks. Now this is slightly off. In fact, let me redo this. So this one is rather tough to draw. So it goes here, it goes up to 4. Uh-oh, that's one more time. Up to 4, comes back down, in this case, to -2, and goes back up again back down like that. I went a little too far, so let's erase the end part of that, because it just goes to -2. So ends about right here somewhere. And so there's a comparison to these graphs. As you can see, now this part right here, it does still extend back down to -2. So we can draw this extension on the graph. Alright, and this graph, it's a little sloppy, but you can see the shift in the graph. And that would be part D. So when it says describe the transformation, really we saw what transformation it was going to make over here. The vertical shift, it's going to shift up once, and it's going to shift to the right pi units. So that is example 2, part D, with the advanced functions and modeling indicators.